Hi, this screencast is on intermolecular forces for AP Chemistry, and in this brief tutorial we're going to talk about some of the background pieces of knowledge that you would need to know in order to go on and look at the intermolecular forces. The first thing is that intermolecular forces are the attractive forces between molecules. The attractive forces between the molecules are different than a bond. For instance, you have ionic and covalent bonding. In an ionic bond, you have the transfer of electrons. One atom becomes an ion, losing an electron, and the other one gains an electron, and their oppositeness of charge creates a physical bond. The molecular bonds, or covalent bonds, are when you have electrons being shared evenly between two separate atoms. Ionic and covalent bonds are much more strong than intermolecular forces. An intermolecular force, I often tell my students, is like when you have a post-it note that sticks to the board. It's an attraction, a stickiness between molecules, but it's not a bond. So no electrons have been gained or lost or shared or anything else that is going on. They are fully a part of the molecule or the atom that is involved. But sometimes, and most often, they have a slight charge or a partial charge that causes them to be attracted to another molecule or atom nearby. You will want to keep in mind that gases, liquids, and solids all have different arrangement of the particles within, and they all have different motion abilities. So a gas is the one that has usually a very loose organization, meaning the gases, the molecules spread out. They have some attractive forces within those molecules and particles, but they are willing to spread out, and it's very weak. The liquids have more attractive forces than a gas, and their particles are closer together, as you can see in this picture, and so they are a little bit more attracted to each other. Typically, they take the shape of the container. No, not typically. They do take the shape of the container, and they are free to move around to some degree. They stay within the liquid area. And then you have solids, which are very strong attractive forces within it. And the particles move, they vibrate, but they don't move in the sense that liquids and gases do. But they have the strongest attraction within their particles. Two types of solids that you could encounter. You can encounter crystalline and amorphous. In a crystalline solid, you have an orderly arrangement of the particles, as you can see in this image in the upper right hand corner. You see that the lines of the molecules are all in straight lines, and they are all ordered. Now in amorphous, you can see that the particles are randomly and haphazardly there, and they don't have a particular pattern. The strength of the attractive forces will be seen between the crystalline and the amorphous. If you have a random pattern, the attraction of the other molecules nearby would be random as well. So crystalline is going to have a better chance of having an attraction. Now, you will see the result of these intermolecular attractions, these IMFs, in boiling points, melting points, freezing points, and other properties which increase or decrease depending on the substance. For instance, water has a really high boiling point for its makeup. If you compared water, which is H2O, if you compared it with H2S, you would see a very large difference in the boiling point because the sulfur does not have the same attractive forces as the oxygen. What really is going on is that in water you have hydrogen bonding, whereas in the H2S there is no hydrogen bonding, and so they have a much lower boiling point because they are able to break away the particles and change from a liquid to a gas. So that's one effect that you can see where intermolecular forces plays a part in the property.